Hello! In this video, we're going to be talking about identifying the domain and range of a function. So the domain of the function is all the potential input values of that function, and the range of a function is all the potential output values of a function. So what I'm going to do is I'm going to do several examples in this video, and in the videos, I'm going to show you immediately what the domain and range is, and then I'm going to talk to you about why that has to be the answer for our function's domain and range. So here's our first graph, and we want to identify what the domain and range of this thing is. And I've already done it for you. It's all real numbers and all real numbers. This bold R represents all real numbers. When we think about the domain, we think about what are the potential values that we can put into this function that we get an output back. What can we put in? So if I think about 0 right here in the middle, I can put in 0 because there's graph up above for that 0. Same thing if I do -1. There is definitely graph there when I choose the x value of -1. And down here at -2, I can also include that because yes, this thing is heading downwards, but it's heading downward with a positive average rate of change. So it's heading towards that direction. So I know that this thing is going to keep on going because I've got that arrow there. So that's telling me that I'm going to reach -infinity. And I can apply that same idea in the other direction. Right here at 1, I can tell that there's an output for our function, so I can put in 1. Here at +2, I know that that is a good input value for my function because there's graph below it. So I can see graph somewhere, so that is part of my input values for my function. I can continue in the same way towards +5 and all the way to infinity because I've got that positive average rate of change. So this is going to continue on and on and on and on. So there is no gap, like I can fill in all of my x-axis. There's no x value that I can't put into this function. So that makes the domain all real numbers. When I talk about the range, I'm interested in what sort of output values do we get from this function. So if I check 5, range is our y values. Yeah, there's an output of 5 right here. So 5 must be part of my range. I can say the same thing with 4. Yeah, the function outputs 4, so it gets all the way up here. And I can tell it keeps going up. I've got that nice arrow up. That's telling me I'm going to go all the way up to positive infinity. At 3, I've got a value. Here at 2, I've got lots of values. I've got one here, I've got one there, I've got one there. Those are all definite values. I can see that the function outputs 2 here, here, and there. Same thing at 1. I've got 3 places where it outputs 1. So the 1 is definitely part of my outputs. Same thing with 0. Down here at -1, now I'm back to only one output for my function, but it is still part of the potential outputs of our graph. So we keep going down, and it really just keeps going down all the way towards -infinity. So that makes our range -infinity to infinity. In this example, I want to try to identify what the domain and range is. I've already identified it for us. It's all real numbers, -infinity to infinity. The reason that it's -infinity to infinity, if I check my domain right here at 1, I can tell I get an output for that function. So 1 is part of my domain. When I get here to 2, I'm concerned that I don't have an output because there's an open circle there, but I do have an output up here. So 2 is part of our domain because we get that output of 4. So I would include 2 as well as everything between 1 and 2. Here at 3, I get an output value of -1, so 3 is also part of my domain. And because this thing has that negative rate of change as we go across, I know I'm going to go all the way to positive infinity. There is something going on here, but it's not affecting what our domain is. Do we get an output? Yes or no? That's all we care about for a domain. Right here at 0, it is definitely giving an output. It's right there at 0. 0, 0 is our output. Here at -1, yeah, I got an output. It's, I don't know, a little bit bigger than 2. I don't know what it is, but that doesn't matter. I got something there. If I go here to -2, still got output. Everything is still part of our domain. And because we have this overall negative rate of change that's going all the way across our graph, we get all the way towards negative infinity. There was no point along this x-axis that I didn't find any place where there was no output. There was always an output. So my domain is all real numbers or negative infinity to infinity. When I talk about the range, I want to check all the values on this y-axis and make sure that that the function outputs that value at some point or another. I'm going to start up here at 5. Yeah, it spit out 5 right over here, so 5 is part of our range. It spit that out. Here at 4, we got 2 values out, so we definitely got 4. We got it twice, in fact. So 4 is definitely part of our potential outputs for this function. Same here at 3, we've got 2 outputs for 3, so yep, that's part of our function. Here we got 2 outputs for 2, so yep, 2 is part of our outputs for our range. I'm a little nervous here at 1. Uh-oh, there is actually nothing there. So maybe we don't have an output. Oh, there's nothing there either, but oh, here, right there. Yep, we do have an output at this point right here where we do get an output of 1. So 1 is part of our range, even though there's open circles here and there. Because of this line, we can continue all the way down. There's all of these outputs where we're hitting -1, -2, -3, -4, and -5. And because this continues down and down and down and down and down, we're reaching all the way down towards negative infinity. So as we move up, we keep going and going and going. And then also right here, we keep going up. So this range hits all numbers between negative infinity and infinity. We are able to get all of those values out of our function. In this example, I want to figure out what is my domain and range. Domain is all real numbers, all real numbers, except the range seems to be limited. So let's start by talking about the domain. Why is that all real numbers? Well, I'm going to start here at 0, and I can tell I'm outputting something at 0. So 0 is part of my domain. Here at 1, yep, I've still got an output. Something weird is happening there, but it's still part of my domain because I do get a value back at 1. We get -3. Here at 2, yep, I've got an output, so that is part of my domain. Here at 3, yep, we've got an output of -1, so that is part of our domain. Here, yep, it's right on that point, so that is still part of our domain. Here at 5, yep, I've got an output. Since I'm getting an output at 5, 5 is something we can put into our function. And because this keeps going with that positive average rate of change, I'm going to get all the way towards positive infinity. If we check in the other direction, -1, I've got an output. Since I've got an output that is part of my domain, -2 works. -3 works because I've got an output there. -4, yep, I've got an output, so 4 works for my range. And I kind of can just keep going because this thing is covering me. And that thing is going to keep going towards negative infinity. So all of these values out here are going to be part of my domain. So that's why my domain, there wasn't a point where I didn't get an output. So my domain is negative infinity to infinity. When I check the range, I can see, oh, there's some values that I don't get output for my range. Let's start up at the top. At 5, I'm concerned about there being an output for my function, but I'm remembering, hey, this thing keeps going up. So if I imagine that thing continuing to go up, then yeah, that is part of my range. So 5 is something that I will eventually get from my function. In fact, even like 6, that will also be a part of it. So this thing's going to go all the way up towards positive infinity. At 4, yep, that's still part of my range. And we're also getting them over here too, because this line is continuing to go up too. So I'm getting 2 values that I can put in for x that'll get an output of 4, because range is like what outputs do we get from that function. Here at 3, yep, I can even see this output here. So the y value of 3 is part of our range. The y value of 2, yep, I can see it there. This event is almost there that I can definitely see it, but like it's going to get there eventually. Here at 1, ooh, I can see both of those outputs, so I'm definitely getting an output of 1. Here when we reach 0, yep, I've got 2 times where I'm able to get that output of 0. So 0 is part of our range. Now we're getting close to the trouble. Here at -1, got two outputs, so that's part of our range. Here at, I went a little far, but -2, yep, that's part of our range. But then at -3, that's the last time I see it. When I get down here at -4, it never outputs 4. All these lines are going up and up. There's nothing down here. I look to the left, I look to the right. I don't see an output anywhere of the y value of 4. We've got an x value of 4 over here. That's fine. But in terms of y, we never get down to the y value of -4. I said +4, but -4. We never reach -4. So this is the lowest that this thing goes. So that's why our range is from -3 to infinity. Our range is -3 to infinity because the lowest that this thing goes is -3. It never reaches down here. I don't get a value of -5. I don't get a value of -4. I want to use a bracket on that -3 because the last point that I've got is a filled in circle. There's a filled in circle here. So that means a filled in circle is going to be a bracket. In this example, we can see that the domain is -infinity to infinity again, but the range seems to be limited somehow. So let's start with the domain. So right here at 0, we are able to have 0 as part of our domain because we get an output. At -1, we are able to include that because we get an output of 3. Here at -2, I am concerned because if it was only this, we wouldn't get an output. That open circle means we approach it, but we don't quite reach it. But we are still getting an output value of 1 here. So -2 is part of our domain because we get that output value of 1. -1, 2, 3 is part of our domain because we get that output value of 3. We're able to have -4 be part of our domain because we get that output value of 2. Same thing with -5 because we get the output value of 1. So all this is part of our domain, and we can keep going because of that arrow going down. That's saying that, hey, all of that stuff is part of our domain. Over here at 1, we get an output of 1. So 1 is part of our domain. Here at 2, we get an output of 0. We're still getting outputs, so that means we're still getting our domain. Here at 3, we get an output of -1. So, yep, that is part of our domain, and we can continue that thinking going forward, that we're always getting these output values down here. So we get a good set of all real numbers for our domain for this function. Our range gives us a little bit of trouble. Let's start down here at the bottom. Here at -5, we know that these lines are continuing down. So there at -5, we're getting two places where it outputs -5. So -5 is part of our domain. In fact, we can keep going down towards -infinity because those things are going to continue going down and continue giving us outputs deeper and deeper into the negatives. Here at -4 is part of our domain. We're getting it over there and over there. We can continue our way up at -3. That we get an output value over here of -3. There's another one over there. -2, I can see it right there and over there. It gets interesting when you hit 1. At 1, we get 3 places we get that output. So 1 is definitely part of our range. So right here we get a output of 1. Right here, we get an output of 1. And right here, we get an output of 1. So all of those values are part of our range. Same thing with 2. But then by the time we hit 4, we kind of run out of graph. This thing isn't continuing upwards anymore. These two arrows are going down. So when I look for 5, I don't see where it's outputting of that y value of 5. Range is talking about those y values, and it never outputs 5. We can put 5 in. 5 is a good input for the function, but it never spits out a y value of 5. Range is our y. So the highest it goes is this value of 4. But the last value is an open circle. So really, there's nothing there. So we just want to get really, really close to that value of 4. So that's why I'm going to put a parentheses at the very top here. So we are going from -infinity all the way up to 4. Read that graph from the bottom to the top. -infinity to 4, just like you would read the x-axis from left to right. In this example, our domain is negative infinity to infinity, or all real numbers, but there's really something strange going on with the range. But let's start with our domain. In terms of our domain, let's start here at 0. I definitely get an output of 0, so 0 is part of our domain. And we can continue that thinking all the way till negative infinity, because I get an output value of -4 and -5 at -1 and -2, and kind of da 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 da, because this thing is going to continue to head towards the left. So we are going to continually get output values as this thing continues to go down and towards the left that will get to negative infinity in terms of our x values. As we head towards the positive, we get a little concerned because right here at 1, I'm like, uh-oh, there's an open circle. So is there graph below the thing? Do I get an output value when I put in an x value of 1? Yes, I do. It's -1. So 1 does get to be part of our domain. When we check 2, yep, we do get an output down here. 2 produces -2, so that is part of our domain. We hit here at 3. Uh-oh, again. Down here, like, uh-oh, there doesn't seem to be a point, but oh, look up here. We do still have a point. So I already actually colored it in because I know the answer is negative infinity to infinity. But the reason that it's still part of our domain is we got that output of 1 when our x value of 3. So 3 gets to be part of our domain. And we can continue that thinking into the positive infinity because this thing is going to continue to head down and to the right. And as it continues to head right, it's going to continue to produce outputs for those larger and larger positive x values. Now the range is having a tough time. We got trouble here for the range. This is weird. Why is it producing that? Well, let's find out. We'll start down here in the negatives. So I can see that I've got two output values at -5 and -6 and negative whatever, because these things are both heading down. So they're both heading towards the y value of negative infinity. So we know we're going to reach negative infinity for our range because we've got those two arrows going down. -5, we've got those two output values. So at x equaling -2, we do have an output of -5. So -5 is part of our range. Same thing here at -4. At -4, -4 is part of our range. When we get up here to -3, I get concerned because there's that open circle over here, but I'm okay because there's a point right here at -3. So -3 does get to be part of our range because this is our output of -3. When x is 0, we're getting that output of -3. Here, I'm concerned again because there's that open circle. So is there a gap? No, there's not a gap. When x is 2, that's covering this gap. So we definitely do get a output of -2 when x is 2. Since we get that output, -2 is part of our range. When we get to here, do we ever get an output of -1? Yes, we do. It's right here. So -1 is part of our range. But when I start looking at 0, when does it output 0? I mean, it's not over here. It's not outputting 0. Over here, it's not outputting 0. So we've run out of outputs. The highest we kind of go is like, we never even get an output of a half. So we have to block off right here and say, hey, we don't go any farther in terms of our outputs to -1. I chose a bracket because I have an equal to with that filled in circle, and equal to's get brackets. And then something really weird happens right here because after that -1, we have one more output that shows up. 1. So we need to start up again here, but then also immediately end at 1 because we just have a single point right there. We don't want 1.1 and we don't want 0.9. So we want to start and end at 1. So we do 1 and 1. But there's a gap in between -1 and 1. So we show that gap with that U. But then it never reaches 2. I don't see any point where I get an output of 2. These arrows aren't pointing up. If they were pointing up, maybe it could cover that, but they're not. They're pointing down. We never get We never get 3, we never get 4, we never get 5. We don't go any higher than 1. So they are not part of our range because we never get that as an output. In this last example, I've got the craziest range yet, so we'll have to see what's going on with that. But let's begin by discussing the domain. So I'm going to start over here this time. You can always start wherever. So at -6, I do get an output value. So -6 is going to be part of our domain. If I go towards the negative infinity, this one is heading down and to the left. So that is going to be part of my domain because I'm going to be continually getting outputs as we go farther and farther to the left because this one will continue to go farther and farther to the left. At -5, I'm worried. There's an open circle there. There could be a gap. I go up. There's still a gap. I still don't see any graph of like any sort of output at -5. So is there a gap here? Nope. Look at this. This single point up here covers us. So at x being -5, we do get an output value of 7. So -5 does get to be part of our domain because we get that output value out here of 7. At -4, we are getting an output value. It's 4, so that is part of our domain. At 3, we're getting the same output again, but it still doesn't matter. We just need to get a output. We don't need to get different outputs all the time, but we just need to get something. Same thing with 2. We get that output value of 4. At -1, we get that output value of 4. So those are all part of our domain. Once we hit 0, now we're worried because there's nothing up there anymore. But don't worry, we've got a point down here to kind of cover us up. So at 0, we get an output value of -4. So 0 gets to be part of our domain. At 1, we still get an output value because this is going to continue to cover us. And it's really small, but it's still part of our domain because while it's small now, as we zoom out, that thing's going to continue to go down and to the right. So as it continues to go down and to the right, that's going to continue to cover us for our domain. So we're going to continue to go towards positive infinity. Now, let's see what's going on with our range. I'm going to start at the top this time. So right here, it seems like we only have a single point. At 6, we don't get any output. There's never a value that we can put in for x that we get an output of 6. So I don't want 6 as part of our domain, but I do want 7 because we got that single point hanging around up there. So I'm going to make an interval that starts and ends at 7. It's just going to be that single point. I don't want 8 because 8's going to be too high. I definitely don't want to get to infinity because I never get to infinity. No, I don't have any arrows pointing up to get me towards positive infinity. The biggest value that I've got on this thing is a 7. So there's that interval that starts and ends at 7. 5, we never output 5. There's no place along here where we get a y value of 5. Now, similar to that dot up top, there's a whole bunch of 4s. There's a whole bunch of values here where we're outputting 4. So 4 is part of our range, but 3 isn't. And 3.5 isn't. And 4.5 isn't. So we, again, want to start and end at 4. There's an open circle here and an open circle here, but there's a whole bunch of filled in circles that are happening at 4 in between these two open ones. So in terms of our y values, we need to be able to, again, start and end at 4. So that's this other chunk. We've got 4 and 7, and then there's a gap in between that 4 and 7. Here at 3, there's no graph. We just talked about that. At 2, I still don't see any outputs of 2. It's never reaching 2. Again, if those arrows would point up, then maybe they could start outputting 2s, but there's never a point where the graph is outputting 2. So 2 is not part of our range. In order to be the range, it's got to be part of the output of the function. Here at 1, it never outputs 1. I don't see any graph here. The closest value that we get after that 4 is this 0. So at 0, we approach 0. We get so close to 0. 0 is almost part of our range, but not quite because we've got that open circle there. So at 0, we're going to start beginning our range, but we're not going to include 0. We're going to get infinitely close to 0, but not include it. That's why we put parentheses at 0, because the range part of this point is open. At -1, finally, we've got a point. We're getting that output value of -1 here at, I don't know, what is this, like -5.2? So this starts to be part of our range, and this thing's starting to cover us. We're getting that output value of -2 right here, so that is part of our range. We're getting an output value of -3 right there. Okay, cool. We're finally getting some range. We're getting two output values of -4. We're getting an output value of -4 here and an output value of -4 here. So -4 is definitely part of our range. And -5 as well. -5 as well. We've got two output values. We got one when x is 1, we get that y value of -5. And we also get that output value of -5 when x is, looks like -6.8, something, I don't know, whatever, doesn't matter. So we got that output, -5, and these are going to continue to go down, so we're going to continue to go down towards -infinity. So that's why when we read our range going from bottom to top, reading our range, we start down here at -infinity, we work our way up to 0. We've got that single point of output of 4, even though there's a whole bunch of them, and then that single point of output of range of 7. So our interval becomes -infinity to 0, 4, and 7. And we write that values of 4 and 7 with these intervals that start and end at 4, interval that start and ends at 7. That is it on that video on how to identify the domain and range of a function from a graph. Note that in this video, I did all of these based on the graph of the function. The best way to find the range of a function is taking a look at its graph and seeing what values that it outputs. Unlike domain, where we're able to do some equation stuff, range, the best way to figure it out is take a look at that graph, see what our output values are going to be. So seeing what this ranger produces as the domain of its function. Domain is inputs, range is outputs. Check that graph, make those little squiggles like I was making inside of this video. Thanks for watching. Bye-bye.